This is Lesson 6 for Unit 3, Composition of Transformations. Some definitions. A composition of a transformation is a combination of two or more transformations. Think about doing a translation and then a rotation, or a dilation and then a reflection. You perform each transformation on the preceding figure, not the original. The notation appears like it would be backwards. We generally think about the first thing coming first and the second thing coming second, but in the notation, the first transformation is closest to the figure being transformed, and then the second. Letter B, glide reflection. It is a special composition where a translation and a reflection are performed one after the other. In a glide reflection, the line of reflection is parallel to the direction of translation. So it says, a special composition where a translation and a reflection are performed together. Notice there was a translation and a reflection. And the line that it's being reflected over is the same line that you're translating in the direction of. So it's just a special composition. Some rules. There are two different ways we can write the rules. We can use words, an ordered pair, anything like that, to describe what's happening to which one. What I'm going to use is the function notation. So you've seen this before, the capital R standing for reflection, the capital D standing for dilation. What this is telling you to do is to start with triangle ABC, and you perform the transformation that is closest to triangle ABC first. So because D, dilation, scale factor of 2, is closest to triangle ABC, that's the one we're going to perform first. You do that and you get triangle ABC prime. Then you take the triangle you just created and you reflect it. Similarly for this one, we're starting with triangle ABC. We're first going to rotate it and second going to translate it. Number 3 says match the composition with each diagram. So look at letter A. You have triangle A out here. We have triangle A prime, and then triangle A double prime. So what happened to get from A to A prime? It appears at a rotation. And then what did we do for get from A prime over to A double prime? Is there was a reflection. So which of the 4 listed below, the square, the circle, the triangle, or the rhombus, describe letter A? Let's see the triangle. Look at letter B. We have A, we have A prime, and then we have A double prime. So let's see. A rotation happened. That's how the orientation from the point up here, it rotated to be over to the second A, or to A prime, and then a translation or a slide. So it's the circle. Let's look at letter C. From triangle A to triangle A prime, there was a reflection and then a slide. This would have to be, we're translating, nope, we're reflecting across line L and then translating, and it says perpendicular, but think about this right here. It's translating away from it, but it's still the idea that we're doing a reflection and then a translation. So letter D, there's only one option left, but let's at least look at this. So triangle A, we did a slide to get to triangle A prime, and then I see a rotation, nope, looks like it was a reflection across the line. So it needs to be the square. So in each of these, a composition of transformations was performed because you did one transformation, you took A, you rotated A to A prime, and then A prime got reflected across. So each combination, each transformation happened to the preceding figure, not the original. One last question tacked on the bottom. It says, which of the following is a glide reflection? A glide reflection involves a translation and a reflection, So which one deals with a translation and then a reflection? I think this is the only one. So it's a glide reflection. Glide, slide, reflection, flip over. All right, writing a rule for each composition transformation. So for the first one, we've got two triangles. We have triangle XYZ, and this should be triangle X double prime, Y double prime, and Z double prime. So I want to know, what can you do to triangle XYZ in order to get it onto XYZ double prime? So the first thing that you do to the triangle is going to go here. This open circle is the symbol for composition. It's not a multiplication symbol, it's an open circle. I'm just kind of telling you to do this one and then do the other one. So what needs to be done to triangle XYZ? I see that triangle XYZ is smaller than triangle X prime, Y prime, and these should be my double of the double prime triangle. So I think the first thing that needs to happen is a dilation. If you look at the ordered pairs, 2, 2, 4, 1, 5, 5, versus the ordered pairs over here, 4, 4, negative 4, negative 4, negative 10, positive 10, there was a dilation of a scale factor of 2. My advice, actually dilate this by a scale factor of 2 so that you can see triangle X prime, Y prime, Z prime. So if I dilate all of these, I'm at 4, 4, 8, 2, and 10, 10. Draw the figure. So here's triangle XYZ prime. Now what needs to happen to triangle XYZ prime in order to get it onto XYZ double prime? If you highlight the y-axis and notice that X prime is 2 blocks away and X double prime is 2 blocks away, you'll see that there's been a reflection over the y-axis. So I think the composition rule states that you take triangle XYZ, first thing I did was dilate it, second thing I did was reflect it across the y-axis. What a lot of students are going to ask is, does the order that you write those matter? And the answer is yes, sometimes it will. For this particular problem though, I don't think it does. So look at this. If I were to take triangle XYZ and I were to first rotate it, reflect it across the y-axis, that would have given my little triangle here, here, and here. And then if I would have then dilated it by a factor of 2, it would have blown up onto the double prime triangle. So for this particular composition, I don't think the order does matter, but please be cautious because the order can matter, and I'll show you that in a second. Second problem, we have triangle ABC, which is up here. This is the original figure. And then we have triangle A prime, B prime, C prime. So what needed to happen to triangle ABC in order to get it onto, those are double primes, A double prime, B double prime, and C double prime. Two things had to have happened. Whatever happens first is going to go closest to triangle ABC, and whatever happens second is going to go furthest away. So you're reading these a little bit backwards. Again, I noticed that the two triangles are different sizes, so a dilation must have happened. Looking at triangle ABC, it is larger. Notice that there's 2 units to the length of CB, and there's only 1 unit to the length of ABC double prime, so there's been a dilation of half. So I'm going to dilate it by half so that I can see triangle ABC prime. 1, 2, 3, 4, 1, 2. So if this is at the point 4, 2, then 2, 1 is going to be A prime. 1, 2, 3, 4, 5, 6. So this is 4, 6. So 2, 3 is B prime. 2, 1, 2, 3, 4, 5, 6. So 2, 6. So at the point 1, 3. So here's prime, B prime, C prime. So I dilated it by a factor of half. Then what needed to have happened in order to get it onto this second triangle? I believe it was rotated in order to get that BC part of the triangle down to this other BC. It was rotated 180 degrees. When you rotate something 180 degrees, the ordered pairs switch. So look at the ordered pair of C prime and look at the ordered pair of C double prime. The signs switched in each one. Look at the ordered pair of B prime. And look at the ordered pair of B double prime. Right here. They have switched signs, so it was indeed a rotation of 180 degrees. If memorizing those ordered pair rules wasn't your forte, then try turning your paper so that the ABC prime triangle is oriented the way you want it. Double check all your ordered pairs. Again, students are going to ask, does order matter? So in this particular case, if we would have taken triangle ABC and first have rotated it about the origin and then dilated it, would it have given us the exact same answer? Let's think about it. If I would have taken this triangle and rotated it 180 degrees, then that means this point of 4, 2 would be at 1, 2, 3, 4, 1, 2. So it would have been down here. And then yes, dilate it by half, it would have worked out to be absolutely the same. Just below that in problem 5 though, these are asking you to perform each translation and to label them appropriately. Please beware that the process is read from right to left. It's telling you to do the second one first, or I'm sorry, it's telling you to do, the second one first. So this is happening first, this is happening second. So start with triangle TEX, do the translation, and then do the reflection. So I have triangle TEX already labeled, so go ahead and do the same. It's telling you to first translate the triangle 0 left or right, and 5 down. Then it's telling you to reflect across the y-axis. So that's what needs to happen. We're taking this one and we're going to move down 1, 2, 3, 4, 5. X prime 1, 2, 3, 4, 5. E prime 1, 2, 3, 4, 5. T prime. Now we're going to take this triangle and we're going to reflect it. So it's, let's see, y-axis. I'm going to highlight the axis. It's 1 away, X double prime. It's 4 away, T double prime, and it's 2 away, so E double prime. So we've performed a rotation on triangle TEX, where we first translated it and then reflected it. Again, someone's going to ask, well, does the order matter? Will it end up in the same place? So this is the one that I did above, and somebody always says, well, I did it backwards and got the same answer. Great, this one worked out, but please beware that it won't work that way every time. Let's try one more. This one's telling you to take triangle XYZ, and it's telling you to first rotate it negative 90 degrees about the origin, which is the same as rotating it a positive 270 degrees. When I do that, these are my ordered pairs that I'm getting for triangle XYZ. X is at